Hello and welcome to our BI4ALL demonstration on stored procedures. My name is Peter Nolan and I'm the founder of Instant Business Intelligence. In this short presentation, we're just going to explain what the idea is behind using stored procedures as opposed to using the business objects universe type products or the Cognos catalog type products. There is actually some thinking behind this that we dreamed up in 2004, and we've used to a relatively lesser extent on our projects since then, but it has been quite successful where it has been used. So I just want to present these ideas behind using stored procedures. Then we'll show you the standards that we have adopted for our stored procedures, and then show you some example stored procedures. Some things here you might find a little bit surprising and hopefully useful. So why use stored procedures? That's a very good question, because the significant problem with stored procedures is that they have different languages across the different databases, and therefore if you commit to using stored procedures for a product that is going to be implemented on different databases, then you are stuck with the idea that you have to maintain multiple versions of these stored procedures. And of course, multiple versions of source code, we all know, leads to inconsistent source code. So when we were thinking about doing stored procedures like this, we had to have good reason to do such. Now, the primary reason was that we were implementing sophisticated data models in those days. In these times, the Sybase IWS data models, and these data models were becoming more and more complex, and we were finding that we were getting proliferation of the business objects universes. We were needing more and more universes, and when we used not that many universes, they were large and slow to update and things like that. And so as the data models were becoming more complex, the universe and catalog tools, such as business objects and Cognos, had to reflect that complexity in their catalogs or repositories. And business objects universes were proliferating, which meant the associated maintenance of those universes. The other thing that we noticed was that the likelihood of errors in reports was increasing, and we were getting more and more instances of the person who was building the business objects universe didn't precisely understand exactly what the underlying data meant, and when they were interpreting what was to be put onto reports from the data model, because the business objects universe designer is the person sitting between those groups, we were seeing more instances of incorrect data or incorrectly calculated and manipulated information being put onto reports that were entirely understandable mistakes. Right? This is not a criticism of the business objects designers. This is noticing that the complexity was starting to defeat people's ability to create these abstraction layers. So we were seeing that. And then the ability to understand what was on the report and to have confidence in what was on the report was being eroded by these kind of mistakes. And presumably, more and more of these mistakes are creeping into production reports. So this increase in coverage of data that goes into the data warehouse, and indeed the complexity of data that's going into the data warehouse, shows no signs of slowing up. Indeed, if anything, the complexity and diversity of data that's being required to go into data warehouses is actually speeding up. We now have the whole concept of textual data warehouses, and how to link the data in the textual data warehouse with the data in the more traditional relational database kind of data warehouse. So a good example of that is the contracts that get signed for banks or telephone companies. The relational database management system just contains flags and indicators for the terms and conditions of the contracts and what options are being purchased, etc. but there will actually be text of said contracts, and different contracts will have different text, particularly with corporate customers. So it is entirely desirable that the text of contracts be associated with the relational records of those same contracts. Something that was pretty much impossible 10 years ago is now becoming desirable. So we see the increase in coverage and complexity of data showing no signs of letting up. And so we are predicting that we will see more errors creep into reports based on an abstraction layer between the database and the end user tool. And that's not a very bold prediction because we're seeing that today. And I would be interested if other people made comment as to whether they're seeing that where they are. So using stored procedures reduces the likely error rates, and the fundamental reason for that is that stored procedures are written by people who know the database very well and who know the data very well. So if we get the people who know the data and the database the best to write the stored procedures, then presumably the level of errors will go down. The other most important item is that the stored procedures can be exposed via many tools. The stored procedure is written once and put in the database once, but it can be executed by any one of a number of tools up to and including Excel. And because the same stored procedures are executing under the covers, that means that consistency in reports and the information being presented to reports will be there no matter which reporting tool is being used to present that information, because the reporting tool itself is not generating the SQL to go against the database to get the information out. The reporting tool is passing a suite of parameters to a stored procedure, and the stored procedure pulls that data out. Now this is the very architecture of report services, and this is in part one of the reasons why we went with report services as a demonstration tool to demonstrate what is now possible in the world of business intelligence. Using stored procedure also actually makes it faster and easier to deliver the same report into the reporting tool of choice for the end user. So, one question that exposes this is how many business object reports are actually replicated in Excel, and the answer to that is rather a lot. Indeed, many accountants use business objects as a query tool to dump data into Excel, and most anybody who's been around business intelligence for long enough will know just how often a query tool is used to dump data into Excel, and all the implications that that has for security of that said information. So by making it faster and easier to build a report with a number of different front-end tools, it's then easier to have a variety of reporting tools rather than the one standard tool. And why have a variety of reporting tools rather than one vendor? Well, reporting tools come in all shapes and sizes with different feature sets, and what has happened in the last 10 or 15 years is companies have tried to enforce a single standard for reporting tools onto the population of the users. That has not been well received, and particularly by the Excel spreadsheet jockeys. So the ability to have disparate reporting tools but not pay a significant overhead for having disparate reporting tools is desirable. The other issue has been that any number of mergers and acquisitions and divestitures and all these kind of things have been going on for the last 10 or 15 years. And so when a company, another portion of a company or something comes into a new parent company, you immediately have the whole issue of, well, if they use different reporting tools, then the whole report suite of one of the companies needs to be rewritten to the other reporting tool. All the data needs to come across into the other data warehouse, etc. And so this has really been a bit of a factor in the mergers and acquisitions area, the whole process of migrating the data either from the operational systems of the acquired company into the operational systems of the new parent company, or migrating the data from those operational systems into some sort of consolidated warehouse so that the reporting for the combined entity can be performed properly. And then, of course, there's the problem in the opposite direction, where the operational systems are meshed for a company, but a company then hives off part of itself and floats it, which was the exact situation in the TalkTalk group when TalkTalk was a part of Carphone Warehouse and then was floated as a separate company on the FTSE. So all this kind of action within the corporate world makes it something of a strain to settle on one single reporting tool for a corporation, because the corporation itself is not so static. So anything that can alleviate or relieve that kind of issue is not a bad idea. So let's talk about the standards that we've implemented in our stored procedures. And we'll just go over to our stored procedures so that we can see some of these standards. This is our one set of stored procedures, and I'll just scroll down the bottom. And this particular stored procedure document is 45,000 lines. So I just wanted you to get the idea that we have a lot of stored procedures. In fact, we have over 60,000 lines of stored procedures which present the data out to any tool that would want to see it via these stored procedures. These are all via SQL Server, just for the time being. So, very simple stored procedure, select currency code. Okay, so all stored procedures are passed a value called user ID, so that in the future, if any customer wants to implement user ID based security, whatever is passed in as the user ID, however that is authenticated, will then be able to apply security at the user ID level inside the stored procedure. So that's the first standard you'll notice. Now in our report services reports, we pass the authenticated Windows user ID into this string. So a typical stored procedure will say select distinct VM currency ISO currency code from VM currency where the primary key is greater than 0, so we don't pull out the 0 record, and union that with a select star and order that by 1. The select star, of course, is the wildcard character, so obviously this select currency code stored procedure is going to be used to populate a pull down in report services for currency codes. This next one, the currency code, is select the currency code but without a star for the wildcard character, and then select a default currency code, select Euro as the currency code because Euro is the default. So that's the very simplest of stored procedures. Moving one level up, we have a stored procedure being passed a campaign group name. So as a parameter, so the campaign group name comes in, the user ID comes in, and it says select star from the campaign hierarchy, where campaign group name equals campaign hierarchy campaign group name, or if you go over here, campaign group name equals star. So obviously the standard is that if a parameter is passed in with the value star, then that is fetch all rows, because this will evaluate to true on the OR side of the where clause. So let's move down a little bit further. We have things like select year name, and year name is pulling the select VM day year name from VM day where the key is between these two numbers, and those two numbers mark the beginning of 2012 and the end of 2016. So it selects those 4 years, unions it with the select star. So that's an example. Select year name default returns 2012 because we're currently in 2012. Select calendar quarter default is selecting 3, just as a demonstration for how it can be selected. Of course, it can get a little bit different. So for select month name, one of the issues in month name is the month names don't sort alphabetically. When you sort the months in January, February, etc., you don't get an alphabetical list. And so here we pass in the year name, but we select distinct the month and the year and the month name, and we union that with 0 as month and year and star as month name, and then we order it by month and year. So the star will appear first, and then the months will appear in their correct order, regardless of the text of the months. Now, something that we wanted to refer to on the slides. Let's resume slideshow. Stored procedures can be defined so that the text document contains a source for many different database languages. So I can write one text document that contains the source code for one stored procedure, and that might provide the code for Oracle, DB2, SQL Server, etc. CTL can process that text file to produce one file for each database the stored procedure is to be delivered to, and the documentation for that is in with CTL. So moving right along to some, I said we're going to look at some simple stored procedures. So let's move along to some more complex stored procedures, planned versus actual. And we'll look at this sort of thing, the parameter standards, the where clause standards, and adjoining standards. But the key piece is PLN-V-ACT. And we'll go look at a more complex stored procedure for PLN-V-ACT. So these stored procedures which are PLN-V-ACT are a planned versus actual. So what this does is go to a plan table, go to an actual table, pull the two data streams together and present them back out, which was a very interesting innovation. It means that data streams can be joined in stored procedures inside the database for plan versus actual rather than via ETL or via any other mechanism, such as reading them into a queue-based product like Essbase. So this is going to select account plan versus actual by year, month, company, company type, status, and product. And underscore TPL means that it's a template. So we see the kind of parameters that are being passed. We have year name, month name, parent company organization, so that's the kind of company hierarchy, and then the account types, and then the product hierarchy, and the account status if we want it, along with the currency code. So very frequently the currency code is passed, very frequently the user ID is passed, very frequently the year, name, and month are passed, so that the query is constrained to something sensible. Now, this is going to be a little difficult to understand, and it is documented within the document called BI4ALL Evaluation Guide. But here is a typical stored procedure which retrieves plan versus actual data, which can be read directly back into a spreadsheet. The outer select is selecting from a temporary table, not temporary as in actually created, but an in-flight table created by the database, and it's pulling out the currency code, year name, etc. Now it's pulling out plan new accounts, plan closed accounts, plan open accounts, and information about those accounts, and then actual product units, actual new accounts, actual closed accounts, actual open accounts. So you can see that there's some dimensional style data, and then plan data, and then actual data. And we're going to see how it retrieves this. The next select is taking care of the cases where nulls are seen either on the plan or on the actual for the joining of the data together. So for example, the plan will go out into the future. So there will not be actuals for that data out into the future. So those fields will be null when they're joined. So when the plan data is out into the future and the actual data is not out into the future, you must use the plan strings for the dimension side and the plan numbers. And you must zero the actuals because there are no actuals yet. And that's what this first piece is doing. It's saying when measures plan temp currency code is null, then use the actual. So if the plan is null, use the actual. So going backwards in history, there may not be plans all the way back in time to when the measures started. So you would need that kind of clause. There is also then when the plan new accounts is null, then set to 0, right? Otherwise use plan new accounts. So when there's no plan number, set it to 0. When there's no actual number, then set that to 0. So that's what this case statement is all about. It's all about taking care of when the numbers don't exist and they're null. And you can see that in the case statements. And there's an example of this in the documentation. And this is another from select. So in this select, we're actually going to a table. So we see this select, and we're selecting these string characters, and this is from the VF account plan table. So here is currency code, year, month, etc., and summing new accounts and summing closed accounts. Now we always use the standard of A for the fact table and summing, and we lay this out. And of course, when we're getting stuff from plan, the actuals have to be set to 0. So if we're retrieving data from plan, these actuals will be set to 0. Now, the tables that are actually needed to perform the join are included, right? And they're included with the full names. So account plan period, VM product, company reporting structure. These tables are needed to perform the join, and if they are not there, the join would fail. Next we see redundant joins start tag and redundant joins end tag as comments. So with these comments, this is actually going to be part of the query. So these are joins which we may or may not want in the future. If we don't want them, we can just do a change all on this to remove the star slash at the end, and a change all on this to remove the star slash at the beginning, and these will then be commented out. Now, why would we put this text in here in the first place? Because this is a template, and somebody might want to copy this template, create a stored procedure, and publish that stored procedure, but also have geography be part of the criteria now. So rather than force them to put that in, we've put it in there as a redundant join, and that is saving the time and effort of some of our future customers. The next thing you see is the where clauses, where we use A for the fact table and the detailed key, joining to the fully qualified name of the view name referenced in the from clause, right? We then have the redundant join start and end again to join those tables which were redundant joins. And again, we can remove these joins by doing a change all on the comment. The next piece is the AND clause, or the AND clauses specifying parameters. So these AND clauses are specifying what tables need to be joined through these keys, but now we're putting our constraints on it. And so these are the fields passed in as parameters. So each parameter must be represented by a line in the where clause. So we're saying that the parent company equals the parameter of the parent company, or the parent company equals star. So you can see by this structure that any parameter that is a star coming in will automatically resolve to true, and most databases are smart enough to remove the constraint at parsing time. So that shows you how that's done. If we go up here, we are summing figures, so we must put the group by in the sum, and at the end of this we must give it a name so that the database can understand where this result set for this query is going to be put in the intermediate processing. We are then doing a full outer join. So we went and got data from the plan according to the parameters. We grouped it, summed it, put it into a temporary working table inside the temp storage in the database. We're now doing another select, only this time the plan fields are set to 0 and the actual fields are being used for sum, and we're going to VF account measures. Now obviously the data must come out at the same level and the same columns must be present to perform a full outer join. Now in this case, in the measures table, we've got the same specified joins, but we have many more redundant joins than we did in the plan table. And this is because measures are generated at a level much lower than plans are generated. Typically plans are created at a very high level. And so we've got all these redundant joins. We've got the same start joins, redundant join start tag and end tag. And then we've got the set AND clauses, joining the tables to the tables that are used. And then we have all the redundant joins, joining the keys in the fact table to tables that are not in use in this actual query. And then we have the AND clauses, joining the values passed in as parameters. So parent company to the company reporting structure parent company, or to star. Then we've got the group by, and then we've got the temp. So this is putting this results into a set of temp, and plan temp, this is the actuals temp, ACT temp. And then in the join, the full outer join, we've got it on the plan temp table and the actual temp table, joining on all the fields in the query that are selected out as character fields. And then we've got the outer all temp, which is the final result set that's going to be returned back through the case statement resolution and the order by. So if we take this thing and we look back up further, we'll see this is the all temp. Select all temp. So the full outer join is putting the result set from the plan and the actuals and the case statement back into this all temp to be selected out of. So that's how we do a plan versus actual now. And this is a very cool idea because it means that in the data model we can have a plan table which is entirely independent of the measures table, and we don't need any ETL or any tools to join these two things together. We can join these two things together at runtime inside the database, and virtually all databases support this kind of query now. This relieves us of a huge burden where we used to do things like um, take the plan and actual and join it together into a cube product like S-base, because the accountants were very much into plan and actuals. Or take this plan and actual and in ETL join it together in another table, which is the combined plan versus actual. Or in a tool like business objects, do one query, one data provider against the plan, one data provider against the actual, and join those together. Now, of course, in business objects, that's a bit of a disaster because the data provider joins happen in the business objects server. So that's not really to be highly recommended. But, indeed, it has to be done sometimes. So the next plan versus actual I wanted to look at was this product plan versus actual. Same sort of thing, organization name, country, suburb, product group, etc. Only you can see that the list of fields is quite a bit longer, and then you have some plan and some actual units. And you can go down here and you can see the same structure applies. This kind of select for all the variable names, all the string type fields, and then the plan, then the actual, then you have the query from the plan table, VF product plan, and then scrolling down you have the query from the VF product measures table with three dotted joins again. You have all the setting of the AND clauses in the where clause. You have the group by, the join, and then the sort. So this is a kind of queries that we're doing inside the stored procedures. Now I did want to take you through and show you something else. Something like this. Now where you see these kind of names, CPA 0100A with a number, this is linked to a report services report. So when you look at a report, if you look at CPA 0100, you can tell that this is a stored procedure that is linked to that report via that naming standard. So let's go and look at SA 0101A, and this has got the year, name, month, parent, company reporting structure, economic block, which is the geography structure, and then the product structure, and it's getting all sales measures. So this is picking up the sale unit amount, extended amount, unit cost, extended cost, taxes, and units, planned sales units. Then it's the actuals for all those, so the actual unit, extended amount, taxes, and sale units. And so this is connected directly to a report services report. So the report services report is going to send to this stored procedure these parameters, and it's going to retrieve from the stored procedure this data. And all that I'm seeing as far as a report goes is I'm seeing a bunch of parameters, I'm passing it information, I'm getting data back out of it, and I'm guaranteed that this is going to be correct. Whereas if I was a business objects developer, I would somehow have to manage to persuade business objects to create code like this, or I would somehow have to do the join in a business objects data provider. But it's fairly obvious that when I'm joining plan versus actuals and things like that, that I'm going to have problems joining that in business objects data provider or any other front-end query tools. It's fairly obvious that such data processing activities are best done inside the database, and all that cleaning up of the data is done for all the case statements and nulls, etc., is done inside the database, and all that comes back is a simple matrix of the data that, or record set of the data that I asked for, meeting the constraints of the parameters that I provided. So this is, in our opinion, a vastly better idea for how to implement um, fairly complex stored procedures rather than try and get the query tool to generate the required SQL for this. Now, something else that I wanted to add was the partitioning strategy for SQL Server 2005. We do have a standard because SQL Server 2005 only had one field that you could partition on. We had to create a partitioning strategy for SQL Server 2005. Now, hopefully this has all gone away in 2012. But we had a partitioning join column where we took the part 1 of the partition column and period, for example, and we use this information to create a partitioning key. And if you look on a lot of the tables that we have in BI4ALL, you will find that they have partitioning keys. The fact tables have partitioning keys. So again, this goes through the sales, first of all, the sales plan table, and then goes through the sales measures table to go get the actuals for the table, for the measures, and the normal join them together on all those fields, order them, and pass them back. Now, if you want to just be convinced at what kind of job we've done on stored procedures, here's BI4ALL 3000. Here is stored procedures. This is our list of stored procedures, and you can see, oops, stored procedures. You can see there are 778 items in this list. So 778 stored procedures inside this database, all defined, all not all documented, but all defined as being able to do all sorts of things against this database. And if we go down here, here are some of the standard kind of stored procedures. So you can see it is quite a long list of all the things, many of the things that you would want to do. Now, where you're seeing SPCTL, these are the stored procedures for the CTL product. And SPM is media, SPR is retail, SPT is telco, SPW is web. So there is a stored procedure over the top of many of the fact tables. We were keeping a standard of having, once we wrote a fact table, we wrote stored procedures over the top of it to expose it. But we've eased off on that standard because we are extending the data model much more rapidly than we are extending everything else. And the reason for that is the most valuable portion of the intellectual property is the data model, not necessarily the stored procedures and the reports. Now, the one other reason why we were so keen on using stored procedures was that we wanted to be able to disconnect the reports themselves from the data model of the database. So if the report itself could be altered or changed or customized as an analytical application without without the need for understanding or touching the data model or database, that would be a very significant improvement in the customizability of reports. And so that was another driver for using stored procedures. It was the process of disconnecting the actual report from the data model inside the database. Which you may then argue says, well, I then can't connect my report to the database through some sort of repository. So in our data dictionary and through the CTL spreadsheet, it's possible to define each field on every report and explain where it comes from to give yourself data lineage from the report back to the underlying table. So we have done that as well. So in this short presentation, it's just 40 minutes. We've talked about what is the idea behind using stored procedures, what are the standards in the stored procedures we have. I showed you a number of example stored procedures. I explained to you that we have about 60,000 lines of these things that form part of the base product which people can use, and then connect those stored procedures through to whichever query tool you would like to use. We use report services as a demonstration tool, but lots of different tools can use stored procedures. Now, once again, I'd like to say thank you very much for your time. We appreciate your time and effort in reviewing this presentation. We trust that you enjoyed it and hopefully learned something from it. Thank you very much.